Welcome you all to the subject of Industrial Engineering and Management. This video will see about the remaining topics of Unit 2. So these are the topics we should be seeing in this today's video. Standard performance, scale of rating, factors affecting the working rate, allowance, predetermined motion study, and method time measurement. To start about this, we have standard performance, the MTM, the PMTS, all those topics are a part of work measurement techniques. So work measurement as seen in, we can refer to the unit first video of your unit 2, where work measurement and time study are a part of your method study techniques. So work study techniques, under work measurement you have a different recording techniques. So this is how a work measurement flow chart is about. So in work measurement you will select, record, examine and measure the quantity of work. It can be done directly or indirectly. There are different ways of doing so. Under direct measurement you have time study and work sampling. Under indirect measurement you have synthetic time, PMTS and analytical estimating. We will see about time study, synthetic time and PMTS in this video. Work measurement is application of technique which is designed to establish the time for a qualified worker to carry out a specific job at a defined level of performance. So the key important term here is the qualified worker. So you have to ensure that you have to measure this performance with a worker who is much more qualified and much more eligible to do so. It's not that you have to record with the worker who has not got any previous experience in doing so. A worker who is, in simple, it is about utilizing an expert worker through which you will be able to measure the standard performance for a particular work. The different work measurement techniques are mentioned here. It can be collected using historical data method, the time study, work sampling, the synthesis method, predetermined motion time system, and your analytical estimating. We'll see about the key important aspect of work measurement techniques in the next slides. So this will give you an idea about how the work measurement techniques and their corresponding unit of measurements are about. If the similar to what your micro motion study is about, micro and memo motion study, where utilization of video camera is very key important. Similarly, you have to look up for time study only when there is a very shorter cycle repetitive jobs, and they are usually for direct work. The second category is your work sampling. Work sampling, the application is predominantly for longer jobs which are having a longer cycle time and the unit of measurement in terms of minutes. Synthetic data and analytical estimating are similar to what has been measured in your previous techniques of time study and work sampling, whereas the unique category comes in terms of MTM. MTM stands for method time measurement, where it is predominantly applied only for manual operations which are confined only to a particular work center. And the unit of measurement here refers to TMU. 1 TMU is equal to 0.006 minute. The reason they are using a specific unit for a specific technique is because they wanted it's been a standard unit which has been fixed predominantly to ensure that this unit indicated that the methodology in which it has been measured is using MTM. Next thing is to go for performance measurement. How do you measure a performance? Performance measurement in general, it's about observed performance by the normal performance, the ratio of observed and normal performance. So how determining normal performance might be quite difficult, but calculating of basic time is a key important aspect of your performance measurement, because a basic time is the one which has been fixed as the ideal time to finish a particular job. The Society of Management Committee has defined the rating that a performance measurement, the worker's rate will be different from each worker. The speed in which the rate at which the worker is doing work will be quite different. So the assessment of a worker's rate to the other workers' concept of rate could be fixed on a standard rating, so that there is no deviation or there is no sort of any differences in the measurement or work measurement of the workers. So there is a need of there is a need to bring out a particular scale of rating which is uniformly followed whenever a performance of a particular worker is measured. So the scale of rating as common, it can be on a scale of 1 to 5, and this scale we usually have call it to be a Likert scale. Likert scale is predominantly in terms of odd numbers. It can be in terms of 5, 7 or 9. The reason why Likert scale are in terms of odd numbers is only then you will be able to find the mid value. If the Likert scale are in terms of 6 or 8, in terms of even numbers, the mid, you will not be able to find the mid value. If it is in terms of 7, the odd number, you could take 4 to be the mid value, 3 on the negative side and 3 on the positive side. So predominantly a Likert scale is used for measuring a worker's performance, and a rating of 5 indicates that the worker is exceptional and he is extremely quick learner with higher skill set, and you need only minimal assistance from others to finish the job. Once we speak about the worker's measurement or the ergonomical aspect of a worker who is doing a job, you need to also consider that you need to provide a proper allowance to the worker, because a now worker will be able to do a job without any allowances. The allowances can be of different forms, but when allowances are the ideal condition or it has a mandatory thing which is to be provided to the worker, it can be personal allowances, constant fatigue allowances, or variable fatigue allowances, which are combined together to call, we call them to be fatigue allowances. So personal allowances is to is need to meet his personal needs, like moving to a washroom or moving to a washroom for any other purposes. So that could be a reason for personal allowances. Fatigue allowances is depends upon the work. If the worker is involved so much in a manual work, then you need to give a proper fatigue. You'll be having a more fatigue, and you need to give a proper allowance to the worker too. So the personal allowance and fatigue allowances, you combine that to a relaxation allowances. So once relaxation allowance is done, then you go for contingency allowances, depends upon the industries, and the policy allowances if applicable. Again, on a case to case basis, if an industry sees that the worker policy is not having any scope of providing allowances to the worker, then this can be ignored. So your contingency allowances, relaxation allowances put together with your standard time and normal time will determine how much of total allowances you need to give to a worker. So providing an allowances is a mandatory requirement to any worker who is involved in doing a job, because without allowances, the worker will break down, which means that he will be overburdened and the entire system will be getting collapsed. Next is your standard time. So how do you measure your standard time? Standard time is the amount of time for a qualified worker to complete a specific task working at a sustainable rate using the given methods and workplace arrangement. It is similar to what measuring your standard time of doing a work for a particular worker at an ideal condition. When your condition is ideal, you have all the required equipment, you have all the raw materials, you have all the methods to its place, then you have to and the worker is also fully qualified and highly skilled, then you have to calculate the time which is the particular worker is taking to complete the job. Once the standard time is calculated, the personal allowances which we have seen in the previous slide, all your personal allowances, fatigue allowances, all those, there is a limit to which it has to be fixed. So personal allowances 4 to 7% of the total time, like use of restroom, water fountain, etc., comes under your personal allowances. The fatigue allowances to compensate for the physical or mental strain. People who are working in a noisy environment, they need to be given an additional fatigue allowances, because they'll be finding much more tired when compared to others who are not working. So how do you calculate your standard time? Standard time includes your work content and your basic time. So you could see that the observed time is not only going to be the standard time, because observed time is if a particular worker is performing at a pace greater than the standard pace, you call them to be an observed time. You also include your rating factor, a scale of rating factor, then you add up your relaxation allowances, that will give you your work content. So the standard time is an cumulative of your observed time added with your rating factor, which will give you your basic time, and basic time when added with your allowances will give you your work content, and work content when added with your contingency allowances will give you a standard time. So this is the standard time you have to fix for a particular worker to finish a job if all the requirements are provided to the utmost level. So how do you calculate your standard time? Standard time is an observed time multiplied by your rating factor, which is also and multiplication of rating factor and your personal fatigue delay allowances. The performance rating factor, if he is working 90%, we will put up an example case where a person is working at 90%, which is slower to the normal 100%, and if he is working 110%, we call them to be working faster. So you have to calculate depending upon the experience of the worker. The calculation or the comparison has to be uniform. An experienced worker should not be compared with a fresher, and at the same time, the manual work which is carried by a worker who is doing physically should not be compared to a person who is doing lesser physical work. So the rating has to be uniform on a common scale. It has to be done. So once the rating is done, you calculate your personal fatigue and allowances. So multiplication of that with your rating factor will give you your observed time, standard time. We'll now see about an example where the total time for an operation of an assembly of an electric switch is considered to be 1 minute, and the rating is 120%, which means that it is above the ideal limit. We have to find a normal time, and if the allowances is 10%, which is provided by the company, then we have to find what's the standard time is. So here we'll start with finding what is your observed time. Observed time here refers to the standard time of making an electric switch, which is 1 minute, and the rating is 20% and allowance is 10%. So we know that normal time is your observed time multiplied by your rating percentage. So that will be 1.20 minute. So once you have calculated this, so you have to calculate the allowances for your normal time, because allowances includes your rating factor too. So the rating percentage is to be calculated, is to be noted down, and that has to be multiplied with your observed time. That will give you your normal time. So 10% of your normal time is 0.12 minutes. So you have to calculate the standard time is summation of your normal time and allowances. So that will be 1.20 plus 0.12 minutes. So cumulative standard time is 1.32. This 1.32 is the standard time for a particular worker to assemble an electric switch on a particular working condition. So that particular working condition here refers to standard operating condition, provided all the necessary equipments, materials, and the layouts are kept in proper places. Another example where an operator manufactures 50 jobs in 60 hours and 30 minutes, and the time includes time for machine setting up. You have to calculate the operator's efficiency. The setting time here is 35 minutes and allowed the time per piece is 8 minutes. These are the data which has been given. So we know that the standard time is setup time plus time per piece and multiplied by the number of pieces produced. So standard time is 35, which is the setting time which is required for the worker to set up the machine. So that will be multiplied with your time per piece here is 8. That is multiplied with the number of jobs which are to be manufactured by the operator. So he is manufacturing here 50 jobs. So 8 multiplied by 50 added up with 35 will give you your standard time. So in terms of hours, which is 435 minutes, in terms of hours is 7 hours and 15 minutes. How do you calculate the operator's efficiency here? You calculate that when compared to your, you calculate that with your actual time. So standard time here, ratio of your standard time and your actual time will give you your efficiency of the operator. So 435 is your standard time which is calculated, and with the ratio of 390. See, 390 here refers to the 6 hours and 30 minutes. 6 hours is 6 into 60, which is 360 plus 30 minutes is 390 minutes. So the efficiency of the operator here is 111%. You could infer that it is well above the required limit of 100%. So the operator is working to his highest potential and is much more efficient to the organization. Now we'll see about the PMTS. What PMTS stands for? PMTS is predetermined motion time system. It is a part of work measurement technique which is used for basic human motions, that are measuring the basic human motion which are involved in building up the time for a job. It is it's kind of a database which includes all the basic elements and their associated normal times put together, through which you will be able to develop a set of procedures, and those procedures can be applied as on the whole to analyze the manual task and establish a standard time for the task. So what are the activities which are included? It includes your reach, grasp, move, and release, which are the key important aspect of a worker who is doing a job manually. Any person who is, any worker who is doing a job manually will incur all these basic human motions of reach, grasp, move, and release, and their corresponding thermalic symbols has to be used, which is discussed in the previous videos. Now a small example of how your PMTS looks like. You could see that a posture of a human arm along with this, what are the various motions have been determined. So you have to calculate, this is going to be creating a separate motion, so you calculate that to be 1, and your palm is going to create a separate motion which is going to be 2, and your forearm is going to, your elbow is going to create a separate motion, and your forearm and shoulders are going to create a separate motion. So all those motions are individually to be noted down along with your thermalic symbols which have been used, which have been predominantly used, and it is also necessary that the corresponding times are also to be noted down. This actually the concept of PMTS, when you put it that in a nutshell, it is similar to how constructing a building is about. So building is, we see building as a combination of doors, walls, beams, bricks, and other things. So similar way, PMTS is nothing but you determine what is the time which is to be taken, cumulative on a cumulative of all those things is cumulative of all those elements will give you a PMTS. So PMTS involves so much of other methodologies to anything, which is MTM, work factor, most. But as far as our syllabus is concerned, we'll stick on only with the MTM is concerned. Though most is one of the more predominantly used common techniques of PMTS, but we'll stick on only with the MTM as far as the restrictions of syllabus is concerned. MTM stands for method time measurement, and it's a kind of a PMTM's technique where primarily in industrial setting to analyze the manual operations of the task. MTM gives you the values for basic hand and arm motions, as we seen in the previous slides: reach, move, turn, grasp, position, disengage. All these comes under. See, it is very important that you need to know what are the basic hand motions. So that is the reason why I kept on saying that the therblics are the core important aspect of this unit, because therblics includes all the 18 basic human motions. You could see that all these are already mentioned in your therblics. So your therblics are the base through which all the recording techniques, all the time study techniques, all the work measurement techniques will rely upon. So when an object is in fixed position, you have to reach it. So that is to be noted down separately. And at the same time, or if the object is located on a bench or it is clumbled together, you have to go to a particular distance and then it has to be reached. So there's quite a difference between both them. Rather than reaching object which is quietly evident or which is quietly visible, rather than to reach an object which is mixed upon with other elements. So it will take some time and you have to look for and add it up with the other therblic symbols will incur additional timings too. MTM, there is a classification of MTM1 and MTM2. So MTM is predominantly for short cycle where the work is highly repetitive, whereas MTM1, the only basic motions of reach, grasp and hold are considered, whereas in MTM2 much more other motions inclusive of your engage, disengage and all those which have been mentioned here will also be considered in MTM2. 1 and 2 there is not much difference. It is only that an upgraded version of MTM1 is MTM2. So MTM2 is much quicker to apply because it is more suited for a longer work cycles, and it gives you a more clear idea about what the shortcomings of MTM1 is about and how you can overcome it. And the unit of measurement for MTM is TMU. It is time measurement units. Instead of seconds, we use that. As I said, the reason why we stick on to a different time measurement units is because it is standardized value, which indicates that if an industry is saying that the particular work measurement is about 1 TMU or 0.001 TMU, it indicates that the unit of measurement here or the methodology used here is MTM. That gives an indication about what kind of different methodologies used for recording techniques. So 1 TMU is closer to 0.036 seconds. When you put that in terms of hours, it will come closer to 0.00001 hours. So these smaller units allow for more accurate and precise calculation. You could look up to how it's like milliseconds and nanoseconds, right? So more smaller the units, more accurate the calculation is without using any decimals. So MTM and TMU are a very key important aspect of your method study and time study techniques. There is not any specific limit to you have to use only this particular technique for a process. Depends on a case-to-case basis and depends upon what are the scope of application. Any method study techniques or time study techniques can be used. But to put together on a nutshell, we have seen about so many time study work measurement techniques which are used in industries for measuring the process as well as the movement of the worker. Right, an ideal method study should improvise the worker as well as the process as well, since it tries to eliminate all the unnecessary movement of the worker, eliminate all the unnecessary process which are carried out. We have been seeing about the worker specific in terms of time study and work measurement techniques through MTM, micro motion studies. All those recording techniques will help to improvise the workers' efficiency by reducing their fatigue, and it provides an overall a pleasant environment for the worker to do their activity. Thank you for your patient listening. We'll stop with this for Unit 2. The next video will continue with Unit 3. Thank you.